Image NASA, JPL, Caltech, University of Arizona, University of Idaho. Earth and Saturn's large moon Titan are the only bodies in the solar system where stable liquids are known to exist on the surface. But on Titan, the second largest moon in the solar system and the only one with a thick atmosphere, the liquids are ultra-cold methane and ethane, filling large, low-elevation seas in the eastern side of the moon and small but surprisingly deep lakes or pools on the western side. During its final flyby of Titan in 2017, NASA's Cassini spacecraft used its cloud-penetrating radar to study those frigid lakes, finding them to be more than 100 meters (300 feet) deep and filled with pure methane, not a mixture of methane and ethane as seen elsewhere. Just as intriguing, Cassini confirmed the relatively small lakes, tens of kilometers across, are well above sea level on the western side of the moon, etched into mesas or buttes rising hundreds of meters above the surrounding landscape. The observations indicate the lakes may have formed when surrounding ice and organic compounds chemically dissolved and collapsed. Similar lakes on Earth are known as karstic lakes, formed when limestone is dissolved in water. Every time we make discoveries on Titan, Titan becomes more and more mysterious, said Marco Mastrogiuseppe, Cassini radar scientist at Caltech and co-author of a paper in Nature Astronomy. But these new measurements help give an answer to a few key questions. We can actually now better understand the hydrology of Titan, along with shedding light on the nature of the deep lakes. A second paper in Nature Astronomy describes what are known as transient lakes, ones in which liquid levels have changed between observations, possible evidence of seasonal changes. One possibility is that these transient features could have been shallow bodies of liquid that over the course of the season evaporated and infiltrated into the subsurface, said lead author Shannon McKenzie, a planetary scientist at Johns Hopkins University's Applied Physics Laboratory. Both papers support the idea that hydrocarbon rain on Titan feeds the lakes and then evaporates or drains into large subsurface reservoirs. Scientists are still puzzled by Titan's different faces, with the hydrology of one side of the northern hemisphere different from its counterpart. Said Jonathan Looney of Cornell University, it is as if you looked down on the Earth's North Pole and could see that North America had completely different geologic setting for bodies of liquid than Asia does. The Cassini spacecraft entered orbit around Saturn in 2004 and ended its mission by diving into the planet's atmosphere in 2017. Over the course of the mission, Cassini's radar system mapped more than 1.6 million square kilometers (620,000 square miles) of hydrocarbon lakes and seas across Titan. Data for the new research was collected during a final flyby of Titan on the 22nd of April 2017. This was Cassini's last hour at Titan, Looney said. It really was a feat. Let's block ads. Why?